Hello. I'm Dr. Marlo Nenel. The topic we are going to discuss is about the basics of immunology. After the session, you should be able to define immunity, describe innate and adaptive immunity, differentiate between passive and active immunity, explain how vaccines work, and lastly, expound herd immunity. Are you ready? Okay, let's proceed. In order for us to understand how vaccines work, it is helpful to understand the basic function of the human immune system. Let's discuss first the meaning of immunity. Immunity means the ability of our body to recognize organisms or foreign substances and prevent them from causing illness. This discriminatory ability to eliminate foreign substances is performed by a complex system of interacting cells called the immune system.
Doc Marl, madalas kong marinig ang terminong antigen kapag tinatalakay ang tungkol sa immunity. Ano po ba ang antigen?
Thank you for asking that question, Rosie. Organisms or foreign substances that enter our body are also called antigens. So, to avoid confusion, we will use the term antigen more often in our discussion. Is that okay?
Maraming salamat at malinaw na sa akin, Doc Marl.
So, in relation to infectious diseases, immunity simply means protection from an infectious disease. If you are immune to a disease, you can be exposed to it without becoming infected or getting ill. There are two types of immunity. These are the innate and adaptive immunity. Innate immunity is the immune system that is present when you are born. It is your body's first line of defense against germs. It includes physical barriers, such as skin, mucous membranes, special cells and proteins, that can recognize and kill germs. The problem with these special cells and proteins is that they can kill a germ, but once the germ is dead, the innate immune system forgets it. It does not communicate any information about the germ to the rest of the body. Without this information, the body cannot prepare itself to fight this germ if it should reinfect the body. Therefore, the main purpose of the innate immune response is to immediately prevent the spread and movement of foreign pathogens throughout the body.
Ang pagkakaintindi ko, ang ubo ay bahagi sa innate immune system. Bakit marami sa atin pag inuubo ay iinom agad ng gamot para mapigilan ito? Tama ba ito na kasanayan?
You are correct, Rosie. Cough reflex is part of the innate immune system. Cough is the body's way of keeping bacteria out of the lungs. Therefore, it's not a good idea to suppress a cough. We don't generally recommend over-the-counter cough medications, particularly among children, because side effects such as sedation, irritability, and behavioral changes tend to outweigh any potential benefits. Talk to your doctor about other effective means of managing cough. The second type of immunity is adaptive immunity. If innate immunity is immunity that one is born with, adaptive immunity is immunity that occurs after exposure to an antigen, either from a pathogen or a vaccination. When your body recognizes antigens, it produces antibodies to fight the antigens. It takes about 14 days for your body to make antibodies. More importantly, the body memorizes this fight so that if it meets the same antigen again, it can recognize and attack more quickly. Adaptive immunity is activated when the innate immune response is insufficient to control an infection.
Doc Marl, totoo ba na kung more active ang iyong immune system, mas malusog ka?
The truth is, if an individual has a hyperactive immune system, the system will start attacking healthy tissues instead of viruses or other foreign substances. As a result, the individual may experience many different conditions, like asthma, allergies, rheumatoid arthritis, multiple sclerosis, and other autoimmune diseases. You actually don't want your immune system to be stronger, you want it to be balanced. Too much of an immune response is just as bad as too little response.
Totoo bang kayang palakasin ng multivitamins ang immune system ng isang tao?
There's no specific medication, nor a single vitamin, that has been proven to boost a person's immune system. Multivitamins are not likely to make any difference to your immune system, unless you're seriously malnourished. It's not going to be the wonder that makes your T cells dance with happiness. When it comes to your immune system, it's the repetitive stuff that matters. Getting enough sleep, balanced diet, washing your hands, and regular exercise. Okay, let's discuss a little detail about adaptive immune response. There are two types of adaptive responses: the cell-mediated immune response, or cellular immunity, which is carried out by T cells, and the antibody-mediated response, or humoral immunity, which is controlled by activated B cells. Cellular immunity deals with antigens from pathogens that are inside infected cells. When T cells bind to infected cells, they release cytokines that cause dissolution or destruction of infected cells. On the other hand, humoral immunity deals with antigens that are freely circulating or outside the infected cells. B cells are activated to secrete antibodies, which are proteins called immunoglobulins. The antibodies circulate in the bloodstream, where they bind specifically to the foreign antigen that stimulated their production. Binding of antibody inactivates bacteria and viruses by blocking their ability to infect host cells. Adaptive immunity can provide long-lasting protection, sometimes for the person's entire lifetime. For example, someone who recovers from measles is now protected against measles for their lifetime. However, other diseases, like influenza or COVID-19, do not provide lifetime protection. This process of adaptive immunity is the basis of vaccination. Now, I have a question for you. Are you ready? The process of innate immunity is the basis for vaccination. Is this statement true or false? If you answered false, then you are correct. Adaptive immunity is the basis for vaccination. Let's have a brief review on the difference between innate and adaptive immunity. Let's compare them according to presence or development. Specificity in response to antigens. The speed of response to antigens. Its potency in neutralizing or killing pathogens. Memory for future response to specific antigens. And the tendency to produce allergic reactions. This time, we will discuss the two basic mechanisms for acquiring immunity. These are the passive and active immunity. Passive immunity is immunity you acquire outside of the body. It is the transfer of ready-made antibodies. Antibodies transmitted from mother to baby through breast milk is an example of a natural passive immunity. It can also be induced artificially through blood products that contain antibodies, such as immunoglobulin. This type of immunity is fast-acting, but lasts only a few weeks or months. Passive immunization is used when there is a high risk of infection and insufficient time for the body to develop its own immune response. It can also be provided when people cannot synthesize antibodies and when they have been exposed to a disease that they do not have immunity against. So, passive immunity is immunity you acquire outside of the body from someone or something else. It is further classified into natural and artificial immunity. Transfer of antibodies from mother to baby is natural passive immunity, while receiving immunoglobulin injection is an example of artificial passive immunity. Is it clear to you now? Please don't hesitate to ask questions to your facilitator anytime during our discussion.
Doc Marl, gaano ba katagal nananatili ang human rabies immune globulin sa ating katawan?
Human rabies immune globulin stays in our body in approximately 21 days. It is infiltrated around the site of the bite and provides rapid passive immune protection. It is administered only once because excessive H-Rig can partially suppress active production of antibody. I have another question for you. Passive immunization activates the immune system. Is this statement true or false? The answer is false. In passive immunization, the individual receives ready-made antibodies from either another person or through injection. This process does not activate the immune system. This leads us to another type of mechanism of acquiring immunity, which is active immunity. Active immunity refers to the process of exposing the body to an antigen to generate an adaptive immune response. The response takes days or weeks to develop, but may be long-lasting or lifelong. One way to acquire active immunity is to survive infection. We call this process natural immunity. Natural immunity is created when a person becomes infected by pathogens. Take for instance, someone who becomes infected with mumps. After the initial infection, the body builds immunity against the disease. This is the reason why people who catch mumps are immune for many decades against the disease, because of natural immunity. The persistence of protection, for many years after the infection, is known as immunologic memory. Following exposure of the immune system to an antigen, certain memory B cells continue to circulate in the blood and reside in the bone marrow for many years. Upon re-exposure to the antigen, these memory cells begin to replicate and produce antibody rapidly to re-establish protection.
Doc Marl, bakit ang ilang mga nakakahawang sakit ay hindi nagdudulot ng panghabang buhay na kaligtasan sa sakit o lifelong immunity?
The duration of immunity varies with different diseases and different vaccines. Lifelong immunity is not always provided by either natural infection or vaccination. Usually, when we get reinfected with a disease, it's not because our body has lost immunity. We get reinfected either because the pathogen mutated and our immune system no longer recognizes it, or because our bodies tend to mount a much lower immune response. Flu virus can mutate its genes easily. Just as our immune systems kill off one version of the virus, another emerges that our immune systems don't recognize. This is the reason why flu vaccines are updated almost every year to match with the new strain of flu virus. However, not all viruses mutate so readily. For example, polio virus can't easily change its genome. That's why we've been so successful at almost eradicating it. The common cold and other viruses like COVID-19 reinfect us, not necessarily because they mutate rapidly, but because our body doesn't usually produce many antibodies against these pathogens in the first place. That's what we're seeing with mild cases of COVID-19. The virus sticks to the upper respiratory tract, where the body does not treat it like a threat. Because we don't know about most of the work our immune system does, we often do not think about how busy it is. But the reality is that, like our hearts and lungs, our immune system is constantly working to keep us healthy. This effort is evidenced by the fact that our immune system generates grams of antibodies every single day. The second means of acquiring active immunity is vaccination. We call this vaccine-induced immunity. Vaccine-induced immunity is acquired through the introduction of a killed or weakened form of pathogen through vaccination. When a vaccine is introduced, our immune system treats it like any other exposure. It means vaccine-induced immunity, just like natural infection, will result in the activation of B and T cells of our adaptive immunity. So, what's the difference? The main difference is that vaccines give us immunity without taking the chance of experiencing severe illness or death that follows natural infection. Furthermore, while vaccines are not 100% effective, they tend to provide more stable immunity than natural infection. So, is it clear to you now? Okay, I will say it again. The advantages of acquiring immunity through vaccination are the following. First, vaccination is safer and minimizes avoidable illnesses and deaths that occur due to natural infection. Second, it provides strong or enhanced immune response compared to immunity that follows natural infection.
Doc Marl, ano ang mangyayari kung ang isang individual ay nakatanggap ng COVID-19 vaccination, ilang buwan pagkatapos nagkaroon ng COVID-19 infection?
That individual will have hybrid immunity. Hybrid immunity refers to infection-induced immunity, or natural immunity, that is further boosted by vaccination. Previous research has indicated that hybrid immunity provides better protection against COVID-19 than either naturally acquired or vaccine-acquired immunity. This finding illustrates the importance of people who've had COVID-19 to still get vaccinated. We have discussed in detail the mechanisms of acquiring immunity. Again, please ask your facilitator if you need clarification in any of the topics we have discussed so far. Now that we have learned the basic components and processes of our immune system, it would be easier for us now to understand how a vaccine works. Vaccines work by imitating an infection, using dead or weakened version of the virus or bacteria, or the new type of vaccine that uses messenger RNA. This type of infection, however, almost never causes illness, but it does cause our body to activate the humoral immune response, to produce antibodies, and cell-mediated immune response, to produce T cells. You can consider antibodies and T cells as the soldiers in your body's defense system. Sometimes, after getting a vaccine, the imitation infection can cause minor symptoms, such as fever. Such minor symptoms are normal and should be expected as the body builds immunity. Once the imitation infection goes away, the body is left with a supply of memory T cells, as well as B cells, that will remember how to fight the disease in the future. If the body is exposed to the same pathogen again, the antibody response is much faster and more effective than the first time around, because the memory cells are ready to pump out antibodies against that antigen. However, it typically takes a few weeks for the body to produce T cells and B cells after vaccination. Therefore, it is possible that a person infected with a disease just before or just after vaccination could develop symptoms and get a disease because the vaccine has not had enough time to provide protection. Some vaccines require multiple doses given weeks or months apart. This is sometimes needed to allow for the production of long-lived antibodies and development of memory cells. In this way, the body is trained to fight the specific disease-causing organism, building up memory of the pathogen so as to rapidly fight it if and when exposed in the future.
Doc Marl, bakit may mga taong ganap na nabakunahan ng COVID o fully vaccinated ay nagkakasakit pa rin ng COVID?
Just like other vaccines, COVID-19 vaccines are not 100% effective at preventing infection. So, some people who are fully vaccinated will still get COVID-19. An infection of a fully vaccinated person is referred to as a vaccine breakthrough infection. Breakthrough infections could either be due to mutation of the pathogen, and our immune system no longer recognizes it, or low immune response after vaccination.
Doc Marl, maaari mo bang ipaliwanag sa amin ng maikli kung paano gumagana ang mga mRNA vaccines?
The ultimate outcome of traditional vaccines and mRNA vaccines, when introduced into our body, is the same. They both activate our humoral and cell-mediated immunity to produce antibodies and T cells. The difference is the composition of the vaccine and the mechanism of how it activates the humoral and cell-mediated immunity of our body. Now, let me explain briefly how mRNA vaccines work. The type of virus that causes COVID-19 is called a coronavirus. The coronavirus has points that stick out all around it. These points are called spike proteins. These spike proteins stick to and get inside the cells of our bodies and make us sick. Because of the critical role of these spike proteins in COVID infection, medical researchers were interested of making a vaccine that will destroy these spike proteins and eventually kill the coronavirus. Finally, medical researchers have learned the code or formula of what spike proteins are made of. Then, they make an artificial protein in the laboratory, called messenger ribonucleic acid or mRNA, with the code or formula of the spike protein attached to it. The artificial mRNA contains code of information that will instruct our cells to make copies of artificial spike proteins. Then, The coded artificial mRNA is packaged in a fat bubble, called nanoparticle. The nanoparticle serves as a vehicle that transports the synthetic mRNA inside the cells. Now, the mRNA vaccine is ready. It contains nanoparticles or fat bubbles, with artificial mRNA in it, carrying the formula of the spike protein of the coronavirus. Now, it is obvious. mRNA vaccines do not contain dead or weakened coronavirus. It does not contain even a small part of the virus. It has only thousands of artificial or synthetic mRNA proteins that contain the formula of the spike protein of the coronavirus. Is it clear to you now? Now, when the vaccine is injected into your upper arm muscle, the mRNA nanoparticles enter into your muscle cells. Then, the muscle cells read the formula, or code, from the synthetic mRNA, and produce millions of copies of spike proteins. These spike proteins are displayed on the surface of the muscle cells. The displayed spike proteins are recognized by the immune system, which produces specific antibodies and T cells to attack them. After the attack, the spike proteins and the mRNA disappear, but the antibodies remain. Your body has learned how to fight the spike proteins if it encounters them again when infected with the real coronavirus. That's how mRNA vaccines work. The last subtopic we are going to discuss is about herd immunity. Herd immunity means resistance to the spread of an infectious disease within a population that is based on pre-existing immunity of a high proportion of individuals as a result of previous infection or vaccination. Although the definition mentions that herd immunity can be achieved through previous infection, the World Health Organization supports achieving herd immunity through vaccination by not allowing infectious disease to spread through any segment of the population, as this would result in unnecessary cases and deaths. If only few people are vaccinated, one infected person can spread the disease very fast. However, when most people are vaccinated, susceptible individuals are protected from infection because ongoing spread is limited. This is herd immunity. The percentage of people who need to be immune in order to achieve herd immunity varies with each disease. For example, herd immunity against measles requires about 95% of a population to be vaccinated. Measles is highly contagious, so more people need to be vaccinated to reach the immunity threshold. For polio, the threshold is about 80%. The proportion of the population that must be vaccinated against COVID-19 to begin inducing herd immunity is not known. Achieving herd immunity with safe and effective vaccines makes diseases rarer and saves lives. We have discussed the definition of immunity: innate and adaptive immunity, passive and active immunity, how vaccines work, and herd immunity. Thank you for watching, and I hope you learned something useful today.